Alright guys, so I've searched YouTube for some videos as to parallel line proofs, and I found a couple that would work. I've posted one on Classroom already, but I want to show you another possibility for this particular proof that I have written here. So in terms of the diagram, I've got two lines, M and N, that are cut by a transversal, and we'll go ahead and call that T. I apologize for the terrible video quality. I don't have my document camera at home, so I'm using my phone. Alright. So in our given, we're given that angle 1 is congruent to angle 2, which is going to be here and here. A couple of things that I want you to notice. We're trying to prove that angle 3 is congruent to angle 4. Now you might want to jump straight into saying that they're congruent by the alternate interior angles theorem, but the reason we can't do that here, if you recall, the alternate interior angles theorem says that if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. And in this case, we don't have parallel lines, at least it's not stated. They appear to be parallel, and we'll in fact use the fact that they are parallel. But since it's not given that they are parallel, I can't use that directly in the proof. However, if I can show that the lines are parallel, then I can use that theorem. Now, in terms of this proof, there's a couple of ways you could approach it. We could do this previous to knowing the alternate interior angles and all of that using simple vertical angles and the transitive property. So here you'd have a pair of congruent angles with 1 and 3. There you'd have a pair of congruent angles with 2 and 4. And then your transitive property would give you that 3 and 4 are congruent. So you could go about this in a way entirely different than what I'm going to show you here. But since we're dealing with the converse theorems and parallel lines and transversals, we want to see what we can do with those. So let's look first at our given angle 1 is congruent to angle 2. So looking at that, I can see that they're a pair of alternate exterior angles, and you'll recall that we have a converse of the alternate exterior angles theorem that says that if two lines are cut by a transversal, so that a pair of alternate exterior angles are congruent, then the lines are parallel. So what this allows me to conclude, if angle 1 is congruent to angle 2, then that tells me that line M must be parallel to line N, and that's by the converse of the alternate exterior angles theorem. Now this goes back to what we just talked about. If I have two parallel lines, then I know that angle 3 is congruent to angle 4, and in this case we'll go ahead and write that next. If two parallel lines are cut by a transversal, then a pair of alternate interior angles are congruent, which is our alternate interior angles theorem. And that completes the proof. So in terms of, like I said, you could use it with the transitive property. It's going to be just about the same length. It's not going to necessarily be any longer. It's just an alternate way of solving that particular proof.